Welcome to Pomodoro Joe for Saturday, September 30th, 2023. Today we're looking at LeetCode problem 456, 1, 3, 2 pattern. This is a medium problem. Given an array of n integers, nums, a 1, 3, 2 pattern is a subsequence of 3 integers, nums index I, nums index j, and nums index k, such that I is less than j and j is less than k. So that's 3 integers or 3 indices, one to the left, one in the middle, and one on the right. And nums index I is less than nums index k, which is less than nums index j. So that means the number on the left is less than the number on the right, and that's less than the number in the middle. So that's why we get the name 1, 3, 2 pattern. Number on the left is the smallest, number on the right is the middle, and the number in the middle is the largest. Okay, return true if there is a 1, 3, 2 pattern in nums, otherwise return false. And then we have an example here. So we have 1, 2, 3, 4, and the answer is false because there's no pattern in which the number to the left is less than the number to the right, which is also less than the number in the middle. Let's see example 2, 3, 1, 4, 2. All right, so this one is true. And the reason is because we can have 1, which is smaller than 2, which is smaller than 4. Okay, so let's put 25 minutes on the Pomodoro timer, and we will get started. So this is an interesting one. I think what I'll do is actually take a 2-pass approach. I'll do a first pass. I can pre-calculate all the numbers to the left of a given index to see which one is the smallest. So essentially I'll just go through my entire array, keeping track of the smallest number I've seen so far. And then I can store that in a new array that's basically just saying, at this index, what is the smallest number to my left? So that's the first pass. Then in the second pass, I need to keep track of numbers to my right. So I think I actually need to traverse my array from right to left, keeping track of the smallest numbers on my right. Now, unfortunately, I think it's a little bit more complicated than the left to right approach, because when I move from right to left, I not only have to keep track of the smallest number, I have to know the smallest number to my right that's still larger than the smallest number to my left. So let's do this. We'll start with some result. We'll set it to false to begin with. We'll return the result at the end. And let's see, let's do our 2 passes. So first pass, pre-calculate smallest numbers to the left. Okay, so for this, I'll just have my smallest number I've seen so far, and we'll set it to infinite to start with. And then let's see, I need to have my array, so smallest to the left. And let's see, I can start this as an infinite array times the length of my nums. All right. And then for every number in, actually I'm gonna enumerate these. So for every index and number in enumerate, and let's see, this will be my nums. So enumerate will just give me the index and the value. All right. Okay, so if this number is less than the smallest number so far, then I'll replace the smallest number with this number. And then I'll put this number into my array here. All right. So now I've gone through and I've pre-calculated the smallest number to the left of any given index. Great. Now I'll be moving from right to left. Now at this point, I'll be keeping track of all the numbers to my right. I need to make sure I have numbers to the right that are greater than the smallest number to my left. And I'm looking for numbers that are to my right that are greater than the smallest number to my left, but smaller than the current number. So let's see, how am I going to do that? Well, let's see, for every index in range, and let's see, I'll be moving from right to left. So I'll go from length of nums minus 1, and I'll go down to -1, and I'll take steps of -1. So that's moving from right to left, so moving backwards. Let's see, I need to get my number out. So nums at this index. All right, and let's see, let's find the smallest number to my left first. So the left, I'm looking for the smallest number. So that's smallest to left at this index. That's going to be I. Is it this index or is this index -1? I think it's actually this index -1 because in here, I'm actually storing the value at the index, so I actually need to look at the previous index. Oh, that also means I don't want to go down past 0, so that's a little tricky. All right, so we'll just go down to, but not including 0. That means I can look to the left at 1 minus 1, that's index 0, and that's going to be where we stop. Okay, so that's to my left. Now the number itself, I've already calculated, that's this n. Now I'm looking for the number to the right. All right, so the right, I need to find the smallest number to the right that's still greater than this number to the left. Okay, so I need to keep track of my numbers to the right. I could keep track with an array, but I think if I'm looking for something that's the smallest number, the thing that pops into my head is, why not use a heap? So let's try using a heap. All right, so out here, I'll need some heap. Now this heap will store all the numbers to the right, but at this point, because it's a heap, it'll be surfacing the smallest number to the top of the heap. Then I can go through and actually pop things off the heap while it's greater than, or sorry, while it's less than or equal to this left value. So let's see, the right will need to pop some value off the heap. So that's going to be heap at index 0, but I need to actually calculate my heap or go through my heap first before I get this number. All right, let's start our heap with infinite, so it's got something in there. All right, so while the top of our heap, or while we have a heap, I should say, and the top of our heap, that's going to be heap at index 0, while that is less than or equal to my left value, so essentially I'm saying I'm looking for something on the right. The heap is going to store all the numbers to the right, but of course they're sorted in a way such that the smallest number is at the top of the heap, so that's heap at index 0. Now while the smallest number on my heap is less than this value to my left, then I'll pop those off the heap because I'm looking for a value to the right that's greater than this value to the left. All right, so I can just do a heap dot, it's a heap q dot heap pop, and I pass in my heap, and I don't need to pass in any other values. All right, so at this point, the value on my right, to the right of this number n, will be the top of the heap. Now that could be infinite. So now we check to see if this satisfies our requirements. So if the left value is less than the right value, and the right value is less than this value, then we do satisfy the requirements and we can return true. Now in some languages, you can't do this type of comparison, like 3 in a row like this, so you might have to do, well, left is less than right and right is less than n. Either way it will work. Now down here, we do have to put this number onto the heap. Now that we're moving on to the next number, so moving from right to left, we're moving to the next number, then we do need to do a heap q dot heap push, and we'll push this number onto our heap. So we actually have to pass in the heap first, and we push in this number n. Okay, so we're going to go through essentially adding things to our heap as we move from right to left, and along the way, we're going to check out each one of our numbers. Is this number, does it have something to the left that is less than this current value, or what is the smallest thing to the left? And then we'll find the smallest thing to the right that's still greater than the smallest thing to the left. And if we do find this satisfies our requirements, then we can return true. Otherwise, we keep going until we get to the end, and then we have to return our result. Whew. All right, let's see how we do. All right, let's see. Smallest to left. No, I did call it smallest num. Man, my eyesight must be terrible because it's saying name smallest to left is not defined. Did you mean smallest to left? What? Aren't those the same? What's different about these? Oh, that's low. Super tricky. 2 pixels off. All right, try that again. Okay, so that seems to work. Let's see if we can pass all the tests. And we pass. All right, and we do okay. Actually, no, we don't. We do terribly. Look at that, it's terrible. 5% for runtime, 98% for memory though. So hey, I'll consider that a win. Unfortunately, I think that is it for me. There are better ways to do this. I suggest you check them out. Actually, if you jump in here, you can go to the very top here and you can check it out. Look how compact that is. That's beautiful. All right. Well, that's it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.